Hello everyone, thank you for signing in and watching my live stream. I'm Mr. Matt and this is Dr. Tot. You want a cookie, Dr. Tot? Yes. And welcome to Algebra 1. This week we're going to be talking about the absolute value function. We talked about it a little bit last week, but not as much as I would have liked to have. So I made it the topic of this week because it is pretty important. It is a very common and famous piecewise function. So last week we were talking specifically about piecewise functions, graphing them, writing equations for them, evaluating them at specific points. And this week I want to talk about a very specific type of piecewise function, and that is the absolute value function. The absolute value function looks like a V. So parabolas look like a U. The absolute value function is a V. And it's also restricted to its domain. So it's a mirror image of each other. Excuse me, I should say it's restricted on one half from 0. It's the graph of the line negative x. From 0 to positive infinity, I should put it that way, it's the graph of y is equal to x. The absolute value in general, the actual definition of the absolute value is the distance from 0 on a number line. Now practically, that just means that it turns all negative values positive. But the reason that it does that is because -3, for example, is 3 units to the left of 0, and +3 is 3 units to the right of 0. They're both 3 units from 0, so the absolute value of -3 and the absolute value of +3 are both +3 because they're 3 units from 0. You can see where there's a crossover there, that there's a phenomena where the two different inputs produce the same output. That's going to be important when we talk about equation solving with absolute values, just like with the when we take the square root of both sides when we're solving an equation. You're going to have to consider the positive and the negative because squaring eliminates the negative inputs. -3 squared, excuse me, -3 squared is +9 in the same way as +3 squared is +9. So we have to account for that phenomena by taking, when taking the square root, considering the positive and negative, the plus or minus result. The same is going to be true, or in a very similar fashion, for the absolute value functions. But we'll get there at that point. For now, let me share my screen with you. And again, these are live sessions, so there's a little bit of a delay, but I'll keep track of the broadcast screen. If you need me to scroll up or scroll down, just let me know. If you have a question at any point, feel free to post it in the live chat forum. If you're watching this recording, then do please comment in the section below, and I will get to them as soon as I possibly can. So, the absolute value represents the distance from 0 on a number line. So if we were to just look at the absolute value function in general, I have a graph here. I have an x and a y-axis. Let me get the same color as I used before. I think it was this one. So we have the x and the y-axis. Oh, it's a little darker. That's okay though. So if we're evaluating the function y is equal to the absolute value of x, at the input of -4, but the absolute value of -4 is +4, right? Because the -4 is 4 units from 0 on a number line. So if you think about a number line with 0 right here, -4 is 4 units on a number line, just as +4 is 4 units on a number line. So the absolute value of -4 is +4. So when x is equal to -4, y is equal to +4. For the absolute value of -2, that's going to be +2. The absolute value of -1 is +1. The absolute value of 0 is 0. The absolute value of 1 is 1. Absolute value of 2 is 2. And the absolute value of +4 is +4. So if we plot these points here on the number line, excuse me. So if we plot these points here, -4, +4, -2, +2, 1, -1, 1, 0, 0, 1, 1, 2, 2, and 4, 4. Notice we get this very recognizable V shape. And this is different again from a parabola because a parabola is going to have a U shape. It's going to be curved towards the vertex. But that is the typical absolute value function. You should be familiar with its shape. Again, whenever you see the V, you're pretty much looking at the absolute value. Let's look at these. So again, the absolute value just represents the distance from 0 on a number line. So if I have -32 over here, and I have +32 over here, notice that this is the same distance. They're both 32 units from 0. So the absolute value of -32 is 32. I'm going to give you 1 minute. Please look at 2, 3, and 4 and evaluate those absolute values. So 14, the absolute value of +14 is just +14 because 14 is 14 units from 0 on a number line. The absolute value of -15 is +15, and the absolute value of -220 is +220. Again, for all practical purposes, it just turns everything positive, but the true definition is its distance from 0 on a number line. If you have any questions, then please let me know. Now I want to talk about transformations of the absolute value function. Now this is actually ubiquitous to all parent functions, well, many different parent functions. Ubiquitous meaning like uniform or like occurring, commonplace, occurring throughout mathematics. This form allows you to visualize a stretch or shrink factor, and then also a how to pick the graph up and place it into another position where the vertex is at another point. So you might have noticed that the absolute value function, the parent function, which is the simplest form of the absolute value function, this guy, actually let me fix that x-axis. So as we just drew, this guy looks like this. And notice that the vertex of the parent function is at 0, 0. We're going to think of that as h, k. That is this h value, which represents your horizontal shift, and this k value, which represents your vertical shift. Now, what makes it a little tricky is that the h value, notice, has a negative sign, whereas the k value has a positive or addition sign in the translational form of this formula, or of this form. So what that means is that the h value, or your horizontal value, I like to remember it as opposite common sense. Because of the negative sign. I'll put that in brackets. And I like to think of the vertical shift as with common sense. And I know that might be a little bit of a strange phrase, but that's just how I remember it. It makes it easier for me to understand, and that's because this has a positive addition sign. So what that means is that when you see something inside of the absolute value function bars, so next to the x there, that h is going after the x directly inside of the absolute value bars, when you see that value, it's the opposite sign. The result will be opposite of its sign. So normally, with respect, if we know that h is the horizontal shift factor, that means that it's changing the x coordinate of the vertex. Normally, in reference to the x coordinates, -3 would usually mean left 3, or it would imply, with common sense on the x-axis, left 3, because the negative values are to the left of 0, right? But it's opposite common sense. So if you had x minus 2 inside of the absolute value bars, that's actually a shift right 2. Whereas the k value goes with common sense. So if you had a k value outside of the absolute value bars, that's how you tell the difference between the x and the k and the h. The k is always outside of the bars, and the h is inside of the bars, going right after the variable x. So if the k value was, let's say, a +3, that goes with common sense. That means up 3, because k is your vertical shift, meaning that it represents a change in the y coordinate of the vertex. So changing the h and the k values are a way of picking the graph up and placing it at another value. What we haven't talked about yet is this a value. So this a value is a stretch or shrink value. I'm going to call it a factor. And so, and I'm going to list this down here, when a is equal to 1, there's no change. Okay, it's just the normal, right? Because if we have 1 out front of that absolute value function, it doesn't change anything at all. If a is greater than 1, and actually let me write this as arrows. If a is greater than 1, then this is a shrink factor. It's going to make the graph narrow. So tall and narrow. If a is in between 0 and +1, notice not negative, but in between 0 and +1, that's a stretch factor. This is going to make the graph wider and shorter, respectively. I mean, these graphs are infinite, so it doesn't really make much sense to be shorter if you're infinite. But within that window, within the same viewing frame, the second value, the stretch factor, the stretched absolute value would seem shorter. So for example, let me change these into different colors. Oops. Let me make this one green. And I'll make this one blue. So let's just look at this. So if this is my standard function, actually I should be doing that in red. So the red is where a is equal to 1. So I basically don't have any a value that's affecting the absolute value function. So this is my parent function. This is where I'm going to start. Oop. Apologize, I'm not the best artist. That's why I'm a math teacher. So if the a value were greater than 1, we'd have a shrink factor. It's now going to look something like this. Of course, depending on the magnitude of the a value. Actually, that's not good. If a were in between 0 and 1, then it would look like this. It would be wider. Okay, so this might be y is equal to 1/2 times the absolute value of x. This guy would be y is equal to the absolute value of x. And maybe this guy is y is equal to 2 times the absolute value of x. It may seem counterintuitive that when the a value is greater than 1, it shrinks. It's a shrink factor, but it shrinks because the y is expanding so quickly, so it's getting super tall. So for the same input as x, it's going up 2, 3, 4, 5, however many times larger on the y. So each x is now expanding that many times more on the y. So it's getting very tall. So from that same window or viewing perspective, it looks like the graph is shrinking. If you have any questions, then please let me know. I'm going to give you 4 minutes. I'd like you to look at questions 1 and 2, and I'd like you to graph the following equations. Y is equal to the absolute value of x plus 1, of the quantity x plus 1, so x plus 1 is inside the absolute value bars. And 2, y is equal to the absolute value of x, quantity plus 2, so the plus 2 is outside the absolute value bars. I'll give you 4 minutes. I'll keep track of time in the upper right-hand corner, and I'll update it per minute. Okay, so for the first function, y is equal to the absolute value of the quantity x plus 1. So this is in the form y is equal to a times the absolute value of x minus h plus k. So notice that in this function, a is equal to 1 because it's not listed, h is equal to 1, and k is 0 because we don't have a k. So remember that h is opposite common sense, so if it's plus 1, that's really a shift left 1. So that's the only translation, or excuse me, transformation that's occurring here. So we're only shifting this left 1 here. So if I start off with just the parent function, and remember the parent function is just the simplest form of the function, so that's like y is equal to the absolute value of x. If I shift this left 1, then I'm just going to take the vertex, which is at 0, 0, and I'm going to go left 1. And now I'm going to have the same graph, just the vertex is shifted over 1. Okay, so that is y is equal to the absolute value of x plus 1. I'm going to give you one more minute just to look at number 2 again, and then I'll give you the answer. Okay, so number 2, if I draw an x and a y axis, and I just start with the parent function because that's what I want to compare everything to. Notice how I'm drawing this is I just start at the origin, and with these check boxes, these grid lines in, it's pretty easy because it's just a slope of 1. We have the function y is equal to x basically, or y is equal to negative x. So it's 1 up, 1 over. Or I should say 1 over, 1 up, 1 over, 1 up, 1 over, 1 up. So the effect of that is just the diagonal of each of these squares starting from 0. So that's a little trick if you want to just a simpler way instead of counting them all up. But notice that we have a k value of 2. So that means we're going to be shifting this up 2 units. So from the vertex 0, 0, I'm going to go up 2 units, and then that's my new function. Oops, try that again. Okay, so this guy would be y is equal to the absolute value of x plus 2, and this is y is equal to the absolute value of x, the parent function. If you have any questions, then please let me know. Otherwise, I'm going to give you 4 minutes. Please look at 3 and 4. Okay, so if I start by just plotting off the parent function here, so that's equal to the absolute value of x. If I evaluate this form here, this shift, the h value is plus 2. Remember, the h value is opposite common sense. So if it's plus 2 on the x, that's actually left 2. The k value is with common sense, so if it's minus 1, that's down 1. So I'm going to take this down 1, left 2. So now this guy will be right here. And that is the graph of the function y is equal to the absolute value of x plus 2, quantity plus 1. For the second graph, again, just start with the parent function, y is equal to the absolute value of x. And now minus 1 for an h value, you'd normally think would be left 1, but it's opposite common sense, so that means right 1. Minus 2 as a k value goes with common sense, that's, excuse me, minus 2 as a k value goes with common sense, that's down 2. So I'm going to go down 2, right 1. So now I'm going to be here. And that's the function of y is equal to x minus 1, quantity minus 2. The absolute value of x minus 1, quantity minus 2, excuse me. If you have any questions, please let me know. Otherwise, I'll give you 4 minutes. Please look at 5 and 6. Okay, so now they're introducing a values, but that's okay. First, start off the same way with plotting out the parent function of y is equal to the absolute value of x. So we have a reference point of something to compare this to. So we have our origin at 0, 0. We have an h value of positive 1. That's going to be a shift left of 1. We have a k value of positive 1. That's going to be a shift up of 1. So we're going to go left 1, up 1. So this is our new vertex. But we have this shift, excuse me, this shrink factor, stretch factor, not shrink factor, a stretch factor of 2. So this thing's going to be pulled out by a factor of 2. In order to test that, after we know the vertex, we know that that's the axis of symmetry, is that y is equal to -1 if the vertex has an x-coordinate of -1. So I'm just going to test 2 points, one to the left of -1, one to the right, because remember, these sides are straight lines, right? So we just need 1 point we can connect the two. So I'm going to make a table over here, and I'm going to evaluate, let's say, -4 and +1 for y is equal to 2 times the absolute value of x plus 1 quantity plus 1. So when x is equal to -4, I'd have -4 plus 1, that's -3. The absolute value of -3 is 3. 3 times 2 is 6. 6 plus 1 is 7. So when x is equal to -4, y is equal to +7. When x is equal to positive, and I'm just picking these numbers randomly, there's one is to the left of -1. That's my new vertex, and the other one is to the right of -1. When x is equal to +1, I get 1 plus 1, which is 2. The absolute value of 2 is 2. 2 times 2 is 4. 4 plus 1 is 5. So at 1, I'm going to be at 5. 1, 2, 3, 4, 5. At -4, I'm going to be at 7. 1, 2, 3, 4. 1, 2, 3, 4, 5, 6, 7. So I can connect the dots together, and my new function looks like this. For number 2, again, start by sketching in the parent function. And now examine the shift of the vertex. The h value is -2, so this is going to be right 2, opposite common sense. Actually, let me do this in another color. So this is going to be right 2. Plus 2 for the k value is going to be up 2. So from the vertex 0, 0, I'm going to go up 2, right 2. So this is going to be my new vertex. And now I need to evaluate 2 points to the left and to the right of x is equal to 2, because that's obviously my vertex. It's my axis of symmetry. That's where everything expands from, to the left and to the right. So let's go ahead and evaluate here. I'm going to make a little chart. I just need 2 points, so you don't need a lot. I'm going to evaluate 0 because that's easy, and then I'm going to evaluate +4. So when x is 0, I'm going to have -2. 0 minus 2 is -2. The absolute value of -2 is +2. +2 times 1/2 is 1. 1 plus 2 is 3. So at 0, I'm going to be at 3. At 4, I'm going to have 4 minus 2, which is 2. The absolute value of 2 is 2. 2 times 1 is, 2 times 1/2 is 1. 1 plus 2 is 3. So at 4, I'm going to also be at 3. So this function is going to look like this. If you have any questions, then please let me know. This is going to bring us up to the time of today's lesson. So we'll pick back up on Wednesday with more examples with this, and also evaluating more of the absolute value functions, as well as solving some absolute value equations. If you find these, videos helpful, then please like and subscribe to my channel. Otherwise, Dr. Tot, do you want to say goodbye to everybody for a cookie? Hey, Dr. Tot, come on, you want to say goodbye to everybody? You guys say bye. Come on, you say bye. You say bye? Okay, good boy. It's not very enthusiastic, but it's okay. Thank you guys very much for watching. Please like and subscribe, and I'll talk to you all on Wednesday.